Yes, good morning to all of you. Myself, Mahesh Jagdish Pingle, lecturer Electronics Engineering, Government Polytechnic Ambad. So, dear students, today we are going to discuss a high-level modulated AM transmitter. In our previous lecture, we discussed the low-level modulated AM transmitter. So, whatever the modulation process takes place at the low voltage levels in low-level modulation. So in high level modulation, so what is the basic difference between low level modulation and the high level modulation? Here in high level modulation, the carrier signal power level and the amplitude modulating power level, both signals power level are raised very much high before the modulation process. So in this particular high level modulated AM transmitter, first of all we are raising the power levels of the modulating signal as well as the carrier signal to very much high power level, and then we are doing the modulation. Now, let us have a look over the block diagram of high level modulated AM transmitter. What here we are found is that here stabilized RF crystal oscillator we are using. So what is the function of the stabilization? Because we need a stable frequency at the output side. So that's why for making this particular frequency stable one, we are using a stabilized RF crystal oscillator. So function of stabilized RF crystal oscillator is to generate a carrier frequency which is very much stable one. Now this RF stabilized crystal oscillator frequency, carrier frequency, then it is applied to class A RF amplifier. So the function of class A RF amplifier is to increase the voltage level of carrier signal which is acceptable for class C amplifier, which is nothing but a power amplifier. Now from this class A RF amplifier, the signal is given, carrier signal is given to the class C amplifier, and in class C RF power amplifier, the power amplification process takes place. So at this particular point, means at the output of the class C RF power amplifier, we have a carrier power of very much high level. So high level carrier power is available, which is given to the class C RF output amplifier, in which the amplitude modulation is actually takes place, right? Similarly, the signal which we want to modulate, that is the modulating signal, audio frequency modulating signal, it is firstly given to the audio processing and filtering block. In this particular block, the necessary signal conditioning of audio frequency signal is done, and thus modified signal or what signal conditioner signal, it is given to the class A AF amplifier. Now in class A AF amplifier, the voltage level of modulating signal itself gets increased, and amplified modulating signal we are getting at the output of the class A AF amplifier. Now this amplified signal is then further also given to the class B AF amplifier, which generates the necessary high level modulating signal needed for the modulation process. Now it is said that the modulating signal also amplified to a high power level before modulation takes place. So if we want a 100% modulation, then the power of modulating signal must be 33% of the total power. So if the power of the carrier signal, or if the power of percent modulation, if we want 100%, then the modulating signal power must be of 33% of the total power. So if 1500 watt total power is to be transmitted after amplitude modulation process, then the modulating signal power must be of 500 watt. So what this particular statement highlights that the need there is a need to amplify the modulating signal so as it is to the adequate level and which is acceptable by the class C amplifier, so that the modulation process takes place. Now both the carrier signal as well as the modulating signal, it is given to the class C amplifier. Now your class C amplifier must be a collector modulated transistorized circuit, which we have discussed in our previous lecture, or it may be a plate modulated vacuum tube modulator used. So basically nowadays we are using a transistorized circuit. So collector modulated transistorized circuit is used here. So the modulation process takes place in this class C RF output amplifier, and the amplified power amplified modulating amplitude modulated signal, then it is transmitted with the help of antenna. So this is all about the high level modulation. I will once again repeat the procedure of this operation of high level modulated AM transmitter. So each and every block function I will explain once again. So the stabilized frequency carrier is generated by stabilized RF crystal oscillator. So whatever the output of the stabilized RF crystal oscillator, it is of a stable frequency which is called as the carrier frequency. This carrier frequency is then given to the class A RF amplifier, which will increase the voltage level of this RF crystal oscillator generated carrier signal. Now then it is given to the class C RF power amplifier. Here the power amplification of the carrier signal takes place, then it is given to the class C RF output amplifier. The class C RF output amplifier acts as a AM modulator, and actual amplitude modulation process takes place in this particular block. Similarly, for doing the modulation, we need the modulating signal. So whatever the signal which we want to modulate or superimpose on the carrier, it is first of all given to the audio processing and filtering block. The necessary signal conditioning of the signal, it is done in audio processing and filtering block. Then it is given to the class A audio frequency amplifier. Necessary amplification process takes place in this particular block. Then it is given to the class B AF power amplifier, in which the signal itself gets power amplified. So modulating signal gets power amplified to a high level, and then it is given to the class C amplifier. In class C amplifier, the collector modulation takes place. So modulation process takes place at the collector. So collector modulated transistorized circuit we are using here. So the carrier signal is available at this particular port, the modulating signal is available at this particular port, and the amplitude modulation is done in class C RF output amplifier. And whatever the resulting amplitude modulating signal which is available at the output of class C RF output amplifier, which is further given to the antenna for the wireless communication purpose. So thank you very much.